Hi everyone, this is Dr. Saida Falafini from Cal Poly Pomona. In this video, I'm going to talk about decision tree and how it can be used in complex decision making. We all may have been in situations where we need to make a series of decisions at different points in time, where the effects of every decision affects the future decisions we have to make. So in that scenario, at any point of time when you want to make a decision, you need to think about all possible scenarios that can happen in the future and take them into account in your current decision making. Decision trees are great tools to help us with that complex scenario and help us to find the optimum decisions that potentially can be made. So let's look at one example and see how decision trees can be used. At the marketing process of a soda company. This company has a current asset value of $150K, and they are thinking about marketing a new flavored soda. They have three possible alternatives in front of them. So they can either first do a local marketing of this new product and get a sense of how market accepts or doesn't accept this item, and then go ahead decide if they want to market the product nationally or not. The other alternative that they have is that they don't do any local market test. They just go ahead and market the product nationally and just see what's going to happen. The third alternative that they have is that they don't market the product at all. So the question is that which one of these alternatives is a great choice for this company? So a couple of things we know about the company. If the company doesn't do any local market analysis and just goes ahead and market the product nationally, there's 55% chance that they face success, and there's 45% chance that they face national failure. If the company faces a national success, the value of their asset is going to increase by $300,000. However, if they face a national failure, the value of their asset is going to decrease by $100,000. If the company decides to do a local market study first, they have to pay $30,000 for the local market study, and then there is 60% chance that the market analysis leads to success. And then there is 40% chance that the market analysis leads to failure. If their local market analysis shows a success, there is also 85% chance that if they go ahead and do it nationally, they face success. If their local test shows failure, there is only 10% chance that if they do it nationally, they will face success. In other words, there's 90% chance that if they do it nationally, they face failure as well. So the question is that which one of these alternatives that this company has in front of them is a good decision to make. Before we go ahead and see how decision tree can work on this problem, let's go through a set of definitions that we will use. So if, as we want to draw the decision tree, if we get to a point where we need to make a decision, we can show that by what we call as decision fork. If we get to a point where we make a decision, but the results of the decision is not under our control, and they depend on forces outside and happen with different probabilities, we use what we call event fork. And when we finish the decision tree, the final branches of the decision tree where they don't lead to any other decision fork or event fork, they are called terminal branches. So let's see in this example how this is going to work. So before we get to the to show how basically decision tree work. So let's think about this problem one more time. So if you were if you were working instead of the decision makers in this company, so what would be the first decision that you think you have to make? If you think about it, the first decision that we need to make is, should we go ahead and test this product locally or not? Okay, so the first thing that we have is making a decision about testing this product locally. So we need to draw a decision fork. So a decision fork is drawn using a square, and all possible decisions that we have in front of them are shown as arrows that come out of this square. So here, at this point, we have only two possible decisions, or either we are going to test the market locally or we are not going to test the market locally. So two possible decisions. If we were at the point where we had, for example, three possible decisions in front of us, we would put three arrows coming out of this decision fork. Okay, so let's think about that, the options that they decide to test the market locally. So in that scenario, what would happen next? If we test the market locally, we may observe a local success, we may observe a local failure, right? So the outcomes of these decisions are not under our control. So since there are possible outcomes, several possible outcomes, and they are not under our control, we use an even fork to show those possible outcomes. And even forks are shown by circles, and all possible outcomes are shown by arrows that are coming out of those that are coming out of the even fork. So the two possible outcomes here is local success with the chance of 60% or local failure with the chance of 40%. And those probabilities were given in the problem statement to us as we talked about in previous slide. So let's assume we observe local success. What's happening next? So if we observe local success, then the next thing that is in front of us is making another decision. And that decision is, should we go ahead and market the product nationally or not? So that's again another decision node. And the two decisions that we have in front of us is that, should we go ahead and market the product nationally or don't market nationally? And again, at this point, if you had more than two decisions in front of you, each one of them becomes a separate arrow coming out of this decision node. How about the observing failure in our local test? If we observe failure in our local test with the chance of 40%, we may still decide to market the product nationally or not. So still we have to make that decision that, do we want to go ahead and market the product nationally or not? So again, we have a decision node, decision fork in front of us. So then the next decision we have to make is that, should we go ahead and market the product nationally or don't market the product nationally? Okay, so let's assume we observe a local success and we market the product nationally. What's going to happen next? So if we market the product nationally, we expect two possible outcomes. Either the product will be a national success or a national failure. We don't know exactly which one of them is going to happen. We have no control over them. And as a result, we have to show them by even fork. Okay, so the two possible outcomes of marketing the product nationally is a national success or a national failure, each one of them with its own probabilities. And the values of these probabilities are the ones that we got from problem state. If we decide to not to market the product nationally, then it's the end of the decision-making process for us. How about if we observe a local test failure, but we decide to go ahead and market the product nationally anyway? In that scenario also, the two possible outcomes that we can see are national success or national failure. They're not under our control, so we use even forks to show them. So the two possible outcomes are national success or national failure with their own probabilities that, again, we got from problem statement. And if we decide to not to market the product nationally, that's the end of the decision-making process for us as well. Okay. So this is the end for this part of the decision making for us. However, here we had another decision that we had made to basically not to do any local tests. Okay, so how about this one? If we decide not to do any local tests, is that the end of the decision making process, or there is something that happens afterward? Obviously, we still have to continue with decision making. We don't want to test the product locally, but we still need to decide if we want to go ahead and market the product nationally or not. If we decide to market the product nationally, we have two possible outcomes. They're not under our control. So again, we use even fork to show them. And those possible outcomes are national success or national failure, with the probabilities again that were given to us in problem statement. And if we decide not to go ahead and market the product nationally, that's the end of the decision making for us as well. So here is basically the structure of the decision tree that represents this problem. So if you remember, we said decision trees are used when we need to make a series of decisions over time. So here basically our first decision is, should we test the market locally or not? And the second decisions we have to make is that, should we go ahead and market the product nationally or not? So and then as you can see, the results of our first decision, so the possible decisions that we have to make and the possible outcomes affects the next decisions that we have to make as well. Okay, so this is what we mean by making a series of decisions at different points in time, and how decision trees are going to help us to do that. So after constructing the structure of the decision tree, the next thing we have to do is to find out the money value or the cost associated with each one of these final decisions that we have to make. Okay, so in other words, we have to find out that among all these possible scenarios that can happen in this decision tree, which one of them is the best one and we want to happen. So to be able to do that, we have to first calculate the value associated with each one of these final branches. Okay, so which we call also terminal branch. So let's see what is the final value associated with this terminal branch. So when are we going to end up here? If we decide to test the market locally, and if we observe a local success, and then we decide to go ahead and market the product nationally, and we observe national success, we end up here, right? So in this scenario, what would be the asset value associated with this company? Remember, the company started with asset value of 150K. If they decide to test the market locally, they have to pay the cost of 30K. And then if they see a national success, their asset value is going to increase by 300K. Okay, so the asset value under this scenario is the initial 150K minus 30K for the cost of local tests plus 300K, which is the value added after observing national success. So that leads to 420K of their asset value. How about this other terminal fork? In this scenario, they test the market locally, they observe local success, then they decide to go ahead and market nationally, and they observe a national failure. Again, they start with 150K. Since they test the market, they deduct 30K for the cost of the test. But as we know, if they observe national failure, their value of their asset is going to reduce by 100K. So they start with 150K minus 30K is the cost of the local test minus 100K is because of the national failure, and the value of their asset is going to go to 20K. Okay. The same values will be observed for these two terminal forks. Why? For example, for this one, when we are going to get the end of here, if we test the market locally, we observe a local failure, we still decide to go ahead and market nationally, and we observe a national success. So we start with 150K, we reduce 30K for the cost of local tests, and since we have observed national success, the value of their asset is going to increase by 300K. That's for 20K. Okay. So, and then how about this other terminal fork? Again, this is also a terminal fork because there is nothing coming out of it. So how about these two? So for this terminal fork, when are we going to end up here? If we test the market locally, we see local success, but we decide not to go ahead with the national marketing. So in this scenario, we start with obviously the initial value of the asset of 150K. We pay 30K for the local test, but we don't market nationally, so we don't lose anything, we don't earn anything. So in that scenario, we have 150K minus 30K, that's 120K. And that's the same value that we observe for this similar terminal node here. So do the calculations yourself, go through the scenario yourself, and just make sure whatever this number that I have put here represents the decisions and the outcomes that you face for this terminal node. Okay, how about these other three terminal nodes? So how about this one? When are we going to end up here? If we decide not to test the market locally, however, we decide to go ahead and just do the national marketing, and we observe a national success. So in this scenario, we start with an initial value of 150K. We do not pay 30K for the local test because we decide to not to do the local test. And since we have observed national success, we observe a 300K increase in the asset value. So the value of this terminal node is 150K plus 300K, that's 450K. How about this terminal node? Again, start with the initial value of 150K. Since we do not do any local tests, we don't deduct any value for the local test. But since we have observed a national fail, and then we decide to go ahead and market nationally, but we observe national failure, and if we observe national failure, the value of our asset is going to decrease by 100K. So the value of the final asset, if we end up at this point, is 150 initial value minus the reduction in the asset value because of the national failure, and that brings the asset value to 50K. And in this terminal branch, we only have 150K because why? Because in this scenario, we decide not to do the local test and not to do the national marketing. So we just are left with the initial value of the asset. We don't deduct anything, we don't add anything. Okay, so far we have specified the value associated with each one of these final branches, terminal branches that we may end up at if we go through this decision-making process. Okay, so the next thing that we want to do is to do these calculations and see what are the values associated with each one of these decisions. So we want to do that for each one of these branches in this tree so that we can finally see that which one of the values are more and which one of those branches we have to pick if we are going to be at that point. Okay, so just to pay attention that as we developed the decision tree, we went from left to right. As I was developing the structure of the decision tree, I started from this decision node and went all the way to the right to come up with terminal branches. But as I'm calculating the value associated with each one of these branches and each one of these decisions in the tree, I start doing calculations from right to left. So first I calculate the monetary value associated with each one of these branches. And then as you can see, we are going to continue these calculations and come all the way to the left. So to be able to continue with the rest of our calculations, I'm going to assign a number to each one of these event forks, okay? Number 1, 2, 3, 4, and 4. So you can assign any numbers. And I assign numbers just because I want you guys to know which one of them I'm talking about. That's the only reason. Otherwise, you don't have to necessarily give them any specific numbers, okay? So let's assume we are at this decision-making node. What are the two decisions in front of us? One of them is market the product nationally. The other one is do not market the product nationally. If we do not market the product nationally, the value of our assets is going to be 120K. However, what if we decide to market the product nationally? If we decide to market the product nationally, we have two possible values for our assets. One of them is 420K, one of them is 20K, but we don't know exactly which one of them is going to happen. One of them is going to happen with a chance of 85%. The other one is going to happen with a chance of 15%. Okay, so what is the value of our asset if we decide to go ahead and market the product nationally? You may say, what if we take average of these two possible values? However, in taking a simple average, we give similar probabilities or similar chance to these two possible outcomes, but we know that they have different chance for happening. So if we want to consider the chance of happening in calculating our average, we need to calculate a weighted average when the weight of these values are the probabilities that by which they are going to happen. Okay, so in that scenario, we need to basically multiply 420K by its chance of happening, which is 0.85, plus 20K by its chance of happening, which is 0.50. Okay, and I'm going to do this calculation for not only this even node, but also even for 2 and even for 3. Okay, so and I have put the event forks, the final values associated with the decisions, with the possible outcomes, and then the probabilities. So average of the assets related to node 1 is 420K multiplied by 0.85 plus 0.15 multiplied by 20K. So the final value is 360K. We do similar calculations for node 2 and node 3. So in this decision fork, then we put the values that we found through calculations on top of each one of these event forks. Okay, so 300K is the value we calculated for average of assets. If we go through even node 1, 60K for even node 2, and 270K for even node 3. Okay, so in that scenario, if we are ever at this decision making point, and the two decisions that we have in front of us are either market the product nationally or do not market the product nationally, we know the potential value associated with each one of these decisions. If we do not market the product nationally, we expect the value of our asset to be 120K. If we decide to go ahead and market the product nationally, given these possible outcomes and the probabilities associated with them, we expect to observe the average value of our assets to be 360K. So which one of them is a better decision to go with? Obviously the one that leads to higher value of our assets, and that's the decision of market nationally, which leads to the value of our assets to be 360K. So we put the value of 360K on top of this decision node as well, because it shows that at this point, the decision that we should make is market the product nationally, which is going to give us an expected value of 360K for our assets. How about if we are in this decision-making node? We have two decisions in front of us. If we decide to market the product nationally, we get on average 60K for our asset values. If we decide not to market that nationally, we get 120K for our assets. So which one of them is the better decision to make? Obviously, the 100 not marketing the product nationally, which leads to 120K for the asset value. And again, put the final value that you may observe on top of the decision node. Next is this decision node that we have in front of us. So here also, if we market the product nationally, we expect to observe average asset values of 270K. But if we don't market nationally, we expect to observe asset value of 150K. Which one of them is the better decision to make? Market the product nationally, which is going to give us an average value of our assets equal to 270K. Okay, so as you can see, we are going from right to left and calculating the value associated with each one of the nodes that we have. So what is next? Next, we are going to get to even node 4 and see what is the value associated with this node. So for even node 4, we have two possible outcomes. Each outcome, the first outcome leads to 360K, the second outcome leads to 120K. So the average of the outcomes we may see if we end up at this node is 360 multiplied by 0.6 plus 120 multiplied by 0.4. So the average of asset value at node 4 is 264K. And that's, again, the value I'm going to put on top of node 4, because with these two possible outcomes and the probabilities associated with each one of them, this is what I expect to observe. The probability of local success and the probability of local failure were given to us in the problem statement. So I put the 0.4 and 0.6 based on what was given to us in the problem statement. Okay, so next, what is left is our initial decision-making node. So if we ever are at this decision-making point, we have two decisions in front of us. One is test the market locally, which leads to average asset value of 264K, and the other one is do not test the market locally, which we expect to lead to average asset value of 270K. So which one of these decisions we should go ahead and make? Obviously, this decision, which leads to higher asset values, do not test the market locally, which leads to, as we expect to lead to asset value of 270K. Okay, so what does this decision tree tells us? That if you ever are at this decision making point, the best decision is not to test the market locally, and then when you get to the next decision making point, the best decision is just go ahead and market the product nationally and just see what happens in the future, either a national success or a national failure. You expect an average asset value of 270K. Okay, that's how basically we are going to read the results of this decision node and see what is the set of decisions that has been recommended for us. The next thing that I want to talk about is what we call expected value of sample information. Remember here, one of the first decisions that we had to make was testing the market locally or not. And we had to pay $30,000 for this market test. Okay. Obviously, doing the market test is valuable because it can tell us if the market would lead to success or failure. And we know that if we see market success, the chance of observing national success is a lot higher than not doing any test. Okay, if we don't do any test and we just go ahead and market the product nationally, the chance of observing a national success is only 55%. Okay, so obviously doing this local test is going to give us some information that is going to be helpful in making the second decision, right? So that's the whole idea of decision tree. However, what if they charge us a lot for this local test? Does it worth doing it? If not, what would be the value that you are willing to pay for this local test to get that extra information and to make better decisions in future? Okay, so that's what I want to specify. That's what I call expected value of sample information. What is the value of that extra information that you get through local tests? So remember here, our first decision was either test the market locally or do not do the test. If we test the market locally, we expected to observe 264K for our asset values. Otherwise, we expect to observe 270K. Okay, so if we do the test and do not charge anything for the local test, what would be the asset value here? So basically, we do the test, we get the extra information, we use it in our future decision making, but we are not paying anything for this local test. So that's pretty much equivalent to doing everything that we have done here, draw all the decision tree, calculate the asset values, do the basically back calculations all the way to this point. The only difference is that we don't deduct any money from the asset value in these terminal branches. Okay, so instead of deducting 30K, we deduct 0K in each one of these branches. Okay, in that scenario, the asset value, when we decide to test the market locally but we don't charge anything, basically is equivalent to having the initial value that we calculated, just add the 30K that we initially deducted for the local test back. Okay, in other words, if you do the decision tree again, calculate all the values, the value that you observe for this node will be 264 plus 30K, or in other words 294K. Okay, so this is under the situation that we do the local test but we do not charge any value. And obviously if we do not do the local test and just go ahead with the rest of the decision, we will observe 270K. Okay, so in that scenario, which one of these decisions is better, doing the local test or not? Obviously doing the local test is better because that leads to higher asset value. What if I tell you that I'm going to charge you 10K for local test? Okay, so in that scenario, what would you do? So if I have to pay 10K for local test, then the value of this decision node would be 294 minus 10K. So the value of this node will be 284K, meaning that if I test the market and I pay 10K, I still expect the value of the asset to be 284K compared to 270K if I don't do any local test. So obviously still doing the local test is better. So we still decide to do the local test. But if I charge you 20K for the local test, would you do that? If I need to pay 20K for local test, the value of my asset is going to be 294 minus 20, that's 274K, which is higher than 270K, which is a scenario of not doing the local test. Again, I will continue doing the local test because 274 will be more than 270. Okay, and so pretty much you can see that for as long as the value of our assets while we test the market is more than the value of our assets while we don't test the market, we will go ahead and do the test. So in this example, you can see that the maximum value that we are willing to pay for this local test and do it is basically 294K minus 270K. So as long as I charge you 24K for the local test or less, you are going to do the local test because you get some extra information from this local test that helps you with your future decision making, and the value you pay for this extra information makes it valuable. Okay, makes that extra information valuable, and you don't pay too much for that extra information. So we call the 294K as expected value of sample information. Okay, and so that's what this means. Expected value with sample information, that's the 294K. The 270K is expected value without sample information, obviously, and that's what EVWOI means. If we deduct expected value without sample information from expected value with sample information, the value that we get is the maximum value we are willing